My name is Sven Oehme. I'm the Chief Research Officer for DDN, and I would like to talk about some very exciting benchmark reports that we've broken over the last couple of weeks. And so we run an industry benchmark called Spec SFS 2014, which is something that actually simulates various workloads that have been captured in real customer data centers environments. And so it allows you to essentially replay these benchmarks and then provide an apples-to-apples comparison between different storage technologies. And so let me walk you a little bit through what we actually done. So before I start with that, a little bit of optimizations that we've done on our product GridScaler. So GridScaler is a product that essentially embeds a distributed clustered file system within one of our storage arrays. And version 5 is something that just recently came out, and we have a couple of optimizations I would like to walk you through real quick. So we updated a couple of internal things like firmware drivers, all the stuff that customers don't really care about, but at the end make a significant difference in terms of performance. And the previous result of the previous version, version 5, with an embedded system we got somewhere around 0.8 million IOs per second, and now with the new system we're going to get roughly 1.2 million IOs per second out of it. And when you use the external one, which means the servers for the distributed file systems are not embedded, but they're actually outside the system, we were able to achieve all the way up to 3 million IOs through a file system layer into one of our SFA instances. So, and we basically did all this tuning before we started the world record benchmark attempt that we successfully finished at the end. And I'm going to walk you through how that setup actually looks like. So before that, a very simple high-level overview on the SFA platform. So the SFA platform is a 4U, very dense storage system. We have a lot of different interconnect capabilities, various versions of Ethernet, InfiniBand. We also support OmniPass, and we have a fiber channel connectivity. And inside the box, you can basically have up to 72 SAS drives, so up to 48 NVMe drives. And you can attach multiple enclosures to it, up to several petabytes, to get a massive scalable from a capacity perspective, but also the performance is very, very high. We get about 60 gigabytes per second out of a single array, and up to 4 million IOs per second on the block layer. As I said before, roughly 3 million if you go through the entire file system stack. So let me show you what the setup for the benchmark actually looked like. So we had 19 clients, as you can see on the top. They were connected via InfiniBand to 2 Mellanox switches, so basically connected to one switch which had ISLs to a second switch. From there we connected the GridScaler NSD servers, so these are the servers that provide the file system interface into the SFA system itself. And then we had the SFA system and the bottom, which hold basically 72 SSD drives inside when we run the benchmark. So we run all the different benchmarks that are on the web page. I'm going to quickly flip through the results. So this is the curve for databases. You don't see really much because there is no comparison on it. The point that I wanted to make on the slide is that you see basically the number of simultaneous databases on the various left that are simulated by the benchmark. Then you see the average latency for those databases hosted on the system. And you see basically operations per second and throughput numbers. So the only takeaway from the slide is it's a very nice growing curve. If you look at most of the competitor systems and have a comparison slide, they basically go somewhat flat and then basically very high rocket sky peak up, and that basically shows an overload situation. While on all these curves that you're going to see on the various benchmarks, and I'm not going to talk much about the individual detailed slide, more on the comparison, you see that there's a smooth growth in all of them, which just shows the scalability of the platform itself. So for software builds, you're basically the same. As I said, I'm going to explain this a little bit more in the comparison charts. I only added those basically for more details in case people have specific questions on it. And for VDI, you see also there is a very nice growing curve, and the same is basically for EDA. So the interesting thing is if you put all these results in perspective, what other competitor systems have presented so far and published in the past. So what you see here is a chart that basically plots all the major submissions of the last 12 months on one single graph. So you see most of the curves, as I said before, they kind of go somewhat straight and then either go immediately straight up or they do zigzag or all kind of basically weird figures on the graph. And the red line that you see here basically shows the performance of our system. And we basically did beat the previous #1 world record system by 25%. You want to see your phone rings. Okay, so we beat this by 25 more builds. So this is for the software build. And what software build basically does, it simulates a build environment of somebody who's doing software development and running multiple builds all at the very same time in parallel across a large number of basically compute nodes. And so the key takeaway was we were able, with a just SAS SSD based system, even we have NVMe capabilities in the box, which would lead to an even faster result, but we wanted to publish something that is economically interesting for customers, because with the SAS SSDs we have a much lower price point, but we were still able to beat the previous record by 25% at basically 1/3 of the average latency within the system. So the VDI comparison looks even more interesting. Unfortunately, there are not very many publications to compare to, but as you can see, the two publications that are out there are very, very small. They basically max out at a very, very low number. And as you can see with the DDN results, we basically have a nice growing line all the way to about 800 VDI seeds that are running on one single platform. The database one, as I said, looks very similar. There's unfortunately also here only two publications from other vendors. You can see they max out at a very, very early stage, or they just basically make a straight line, which means they're not very scalable at all. While with the DDN platform, we were showing a very, very nice curve, again, all the way to about 800 database instances running at the same time on the system. EDA is the newest of the benchmark in the spec released series of benchmarks. So this basically also simulates a build environment of software, but it's much more complex because it has front-end and back-end workloads, and there's a lot of details that you can look up what the mixture of the workload is. But it's a less metadata intensive workload like software build. It is a little bit more I/O heavy, but it's much more metadata intensive than VDI and database workloads. And so it's kind of a nice mixture. And also, as you can see here, there's basically an almost flat curve. With the one exception, there is a significant drop here, which is not easy explained. But actually, we saw that dropped twice during the run of the benchmark. So I'm not sure if that's an artifact of the benchmark or where it's coming from, but it's definitely something that was repeatable before we made the submission. So the last benchmark I wanted to present the results is the Exascaler setup. So Exascaler is the second distributed file system that DDN owns, so we give the customer the choice between Gridscaler and Exascaler. They both have their pros and cons and are very good in very different workloads. So with the Exascaler system, which is something that is highly optimized for sequential workloads, we actually published a fifth result where we took basically the fifth #1 spot in the world record area of spec SFS. And so the setup looks slightly different. So we have a lot of clients on the top. They were connected to a switch in the middle, and then directly connected into the SFA platform, because we were running the Exascaler file system within the array itself. So the array has virtual machines running inside where you can basically co-locate applications together with the storage. And so the clients were mounting the file system directly out of the SFA platform. So the results that you see here is again a very nice steady growing curve of throughput numbers with VDA. So VDA stands for Video Data Acquisition, which essentially simulates large number of videos being streamed into a central storage array, and then people like moving forward and backwards within the video to play back things. Think about video surveillance kind of workloads essentially. Again, the graph alone is not very interesting if you don't compare it with others. So this is the comparison across a wide variety of different vendors that published within the last 12 months. So everything from IBM, Cisco, there's multiple different players that publish numbers. And you see we show a very nice steady graph again, all the way to the point where we basically reached the max. And in this system we were able to do 65% more streams than the previous #1 system, while having actually less tries in the system and delivering much more capacity than the previous #1 system. So it's essentially a much lower price point, but still delivers a significant higher performance than the previous system. So we're now working together with Spec on an AI machine learning benchmark. So we try to standardize a benchmark because unfortunately there is nothing standardized in this place. So if you're interested in participating with us, please go in contact with us. We're looking for people volunteering for workloads that we could basically analyze. The outcome or the benefit for you would be we would offer you helping tuning some of these workloads if you have them, because we try to basically not just create a benchmark that is repeatable and comparable to other vendors. We also try to figure out what are the optimal settings of the storage systems to play well in AI and machine workloads. So you're already at the booth, so I don't need to tell you to come to the booth, but we have a lot of other very interesting, exciting demos and various product presentations here. So feel free to talk to us for other things that you're interested in. Thank you.